In this example, I need to find the domain of the function f of x equals the square root of the quantity 3 minus x, all divided by x plus 5. And I need to write the answer in interval notation. Well, quickly reviewing, the domain of a real valued function is the set of x values for which f of x is a real number. And here are things to watch for when finding a domain. Note, this is a list of things that can prevent f of x from being a real number. The first is if you have x in the denominator of an expression. You don't want to divide by 0, so you're going to exclude values that make the denominator equal to 0. Next is when you have x under an even index radical like a square root, fourth root, etc. You do not want to have to take the square root of a negative number, so you set the radicand, that's the name of the expression that lives under the radical sign, greater than or equal to 0. Notice this only applies to even index radicals. If you have a cube root, fifth root, it doesn't apply to those. Lastly, when you have x inside the argument of a logarithm, you do not want to take the logarithm of a negative or 0 number, so you set the argument of the logarithm to be greater than 0. Well, do we have any of those problems in our function here? Notice in the numerator there's a square root, so I definitely have that problem. And then in the denominator, there is an expression containing x, so I also have this problem here. So to find the domain, I'm going to have to take care of these two problems. So going to the next slide, let's take care of the problem in the numerator to start with. It's a square root, so I have to take the radicand 3 minus x and solve the inequality that is greater than or equal to 0. So subtracting 3 from both sides of this inequality, that doesn't change the inequality symbol, I get negative x is greater than or equal to negative 3. Now to get x by itself, I'm going to have to divide both sides of the inequality by negative 1, which will reverse this inequality sign. So instead of greater than or equal to, it's going to be less than or equal to negative 3 divided by negative 1. Negative x divided by negative 1 is x is less than or equal to negative 3 divided by negative 1 is positive 3. So I've taken care of the problem in the numerator. Now I need to take care of the problem in the denominator. We can't divide by 0, so I need to exclude all values of x that make the denominator equal to 0. So you set the denominator x plus 5 equals 0. Just subtract 5 from both sides. I'm going to get x equals negative 5. That's the value I have to exclude from the domain. Is this value in this domain? The simplest way to find it is to sketch the graph. If I have x is less than or equal to 3, if I sketch it on the number line, here is 3. Less than or equal to means I need to shade stuff to the left, put an arrow on the end, and I need a square bracket on the 3. Now, is negative 5 in this part? Yes, negative 5 is right here. So what I'm going to have to do is exclude negative 5. So my domain is going to come in two parts. So the domain of this problem, if I look at my graph, I need this interval that starts at negative infinity and goes to negative 5. I must put parentheses always on infinity and negative infinity, but I have to put it on the negative 5 to exclude it. unioned with the next part. Again, I must use a parentheses on the -5 to exclude the -5, comma 3, and you have to put a square bracket on the 3 to include it. So there is the domain for this function.